Hello friends, I Pankaj Dumka welcomes you all to this particular new course on graph theory. So we'll be discussing about lot many graphs in this particular course, and also we'll be talking about several theorems, algorithms, and we'll be talking about walks and different types of graphs, and also a particular type of graph which doesn't have any cycle known as tree. So, without any further delay, let us start with this topic. So, in this thing, first is what is a graph basically? So, graph is basically a diagram which consists of basically collection of vertices and edges. So, here I am drawing a graph, and these are A, B, C, and D. These are what we call as nodes. And these nodes are also called as vertices, and these nodes are connected with the help of edges. So these are the edges which are connecting these vertices. So in general, I am having two sets. One is for vertices A, B, C, and another one for edges. So it is AB, BC, DC, and CA. So what is a graph? It is a diagram like this, which is basically a collection of vertices and edges that joins those vertices. Okay. So now the question comes that how all this has been started. So this has started with the problem that is Königsberg bridge problem. So let us bring it here. Sorry. So this is the one. So long back in Eastern Prussia, now in Russia, there was one city known as Königsberg, and in that city there is one river known as Prigel, and this is the river on which seven bridges were there. So you can see 1, 2, 3, 4, 5, 6, 7. Seven bridges are there. So the task was to start at a particular landmass. So this is, let's say, landmass A, this is B, this is C, this is D. So the task was to start at any landmass. Let's say I'm starting at A, and again I'll reach A, but the thing is I have to cross each bridge only once. So this problem baffled lot many people at that time. Then came Leonhard Euler, who first understand this particular problem and tried to solve it. And the way in which he solved the problem has now become what we call as graph theory. And it was in 1735 or 36 when he wrote one paper. The title was like solution of a problem to the geometry of positions. I think this was the title. And there, his method of tackling the problem was very simple. What he did, he considered these land masses as nodes. So let's say this is B, this is landmass A, this is landmass C, and this is landmass D. Then he connected these land masses based on the fact that how many bridges are connecting these land masses. For example, A and B, there are two bridges. So he connected them twice. Then A and D, there is only one bridge, that is number 4. So this is the one. And then comes D and C. So again one bridge. So he connected. And then comes B and C. Two bridges are there, 5 and 6. So he connected them with two edges. And then finally, this B and D, they are having one bridge, that is 3. So he connected and then tried to solve this. So This was the genius of Euler, uh, who first tried to understand this particular problem and gave the solution that this does not, this can't happen. So let us again try to understand how we can draw a graph. So consider a party where, let's say, uh, A, B, C, D, E, and F. In total, three and three, six. Six people are there in the party. Let's say A uh, shakes hands with B, A shakes hands with C, and A also shakes hands with, let's say, D. And B shakes, let's say, with C and E, and D shakes his hand with, let's say, F, and E also shakes hands with F. So this shaking hand problem, can we draw it in a graph? Yes, we can. How? Let us say these are the people. We are representing them with the help of nodes or graph. Oh, sorry, vertices B, C, D, E, and F. Now A is in communication or has shook his hand with B, C, and D. So this is B, this is C, and this is D. Very good. Then B has done this with C. So this is the one. Also with E. So where is E? Here is E. Now what about C? C has only shook his hand with A, so it is already there, this edge. Now comes D. D is with A already done. Now I think it is D and F. So D and F, and here E and F. So simple. So what we have done, we have reduced this particular problem of handshaking to this graph. So graphs are very much useful when it comes to engineering. There are so many places where we can apply the understanding of this graph, whether it is electrical circuits or it can be project management, it can be your networking. So many places are there where we can apply the understanding or the knowledge of graphs. So consider one more problem. Consider uh, X is a set which represents the applicants for a particular job. Let's say applicant 1, applicant 2, applicant 3, and applicant 4. 4 applicants are there for certain jobs which I am representing by Y. So this is job 1, job 2, job 3. So applicants A1, A2, A3, and A4, these are the applicants, and J1, J2, and J3 are the jobs. It is said that applicant A can apply for J1 and J2. So A can apply for two jobs, that is J1 and J2. Applicant B can apply for all the jobs, that is J1, J2, and J3. Applicants, here it is not B, it is A2. Applicant A3 can apply for only, let's say, J3, and applicant A4 can apply for J1 and J3. Now let us try to draw this particular graph. So I'm having these as applicants and these as jobs. So what I can do is I can make certain nodes saying that these are representative of applicants and these are, let's say, jobs. Job 1, job 2, and job 3. Now applicant A1 can apply for only J1 and J2. So this is the one and this is the one. Applicant A2 can apply for all the jobs. Applicant A3 can only apply for J3. And applicant A4 can apply for J1 and J3. So in this way, you have developed the connections between job seekers and jobs. So this is a way in which we can convert a real life problem into graphs, and this becomes very much efficient and simple to analyze after that particular problem has been converted into a graph. Now, the question one can ask is whether I am having, let's say, I am having this particular node A and B. So, this is vertex A and this is vertex B. So, can I draw only straight line as an edge, or am I permitted to draw a curved line like this? So, in a graph, the edges can be straight line and they can be uh, curved edges as well. So it is not at all a problem for an edge whether it is a straight line or a curve. What this particular edge is representing is it is representing the relation between two nodes. That's it. Okay. And once you draw a graph, then you should always be in a position to identify the vertices and edges correctly, because in the later videos we will be learning that the counting of vertices and counting of edges plays a very important role. Now, in this lecture, till this point only, in the next lecture, we will be starting with classification of graphs, basic classification, and then we will be learning that how certain important characteristics of those graphs can be understood in a lucid and simple way. So in this lecture till this point only, thank you very much for watching it.